These are the notes for 6.1 graphing exponential functions. Okay, so the first thing we're going to talk about is what this f of x notation means. It's just a notation that means the same thing as y. And so even though we look at our table of values here for y, this would be my x, this would be my y, we take a number and put it in for x here. I go 3 times 2 is 6, minus 1 is 5, so y would equal 5. So on the y equal, on this would go on the other table, for the function table, this would be x, this would be f of x, means function of x. I'm going to do the same thing, so I put in a function of 2, I put in 3 times 2 is 6, minus 1 is 5, so the f of x would be 5. So we can say the function of 2 equals 5. And so anytime we see notation, all it means is it's just another way to write something down. Okay? And the reason we do that is because if I have 5 or 6 functions laying around that are all y equals, it's hard to tell which one's apart. So it's like having 5 mics in the same room. Say, hey, Mike, come here, and all 5 of them come here. Okay? So we name them different names. So we give them like f of x, g of x, h of x, so we can keep them all separate. That's why we do that. Okay? So now with exponential functions, it's time to leave that nice straight line thing and go into the nice curve. So exponential functions, when they're curved lines, they can be increasing, show growth, and growth would look like this. We're going to go up like this. We're pen to right. And decreasing, decayed would go like this. Okay, so decreasing, decay. Growth is always bigger than 1, and we'll get into that on lesson 2. But growth is bigger than 1, and decay shows less than 1, where the b number is. Okay, you can graph using a t-table. We use t-tables a lot to graph these, and then also we can do the graphing calculator to help us with some of that. Alright, when we do our t-tables, the best value we put in our t-tables are -2, -1, 0, 1. And that's because these functions get large really fast, and so we got to keep our numbers as small as we can. Those are the 5 smallest numbers we need. And we need 5 numbers to get a good idea what the graph is. Okay? Alright, so the general form of the expression is f of x, which is the same thing as saying y, equals a, which is our initial amount, so initial amount, and then times our multiplier and our power of x, which goes up there. So that's kind of how we deal with those. So this first problem we're going to work on is changing this to getting this function 5x into the chart here. Okay, so we're just going to take, and the x becomes -2, so this power right here will become a -2. So we'll just work these out. Okay, so our first one, we got 5 to the -2 power. Okay, and we know that negative powers cannot be worked this way. So what we do is we take and push this down to the bottom of the power. And so it becomes 1 over 5 to the +2 power. And then that becomes 1 over 5 times 5, which is 1 over 25. So that value goes right here. That's our b number, 25. Okay? And we'll just keep on going. So the next one will be 5 to the -1 power. Again, this is a negative, so it's got to go to the bottom. It becomes 1 over 5 to the +1 power, which is just 1 over 5. Okay? And then the 0 power, we got 5 to the 0 power. Anything to the 0 power we know is 1, so that's just answers 1. Then we got 5 to the first power, that is just 5. And then 5 to the second power, we know is to be 25. Okay? So that's how we do those by hand on the calculator. Okay? So that's how we fill out that chart. Alright, so just putting those powers in for x and just how to solve them. Alright, so the next page, we're going to do the same thing, except now we're going to graph it. Okay, so we're going to take the same function, we're going to find out what the table of values is. We'll make it ourselves over here. Okay, so this is my x, this is my g of x, because it's a g function. And we're going to put these numbers in here. Okay, the same numbers, -2, -1, 0, 1, and 2. We get these points, we're going to graph them on the graph over here. All right? So, putting these numbers in there, we got 3 to the negative 2 power. Again, that's going to be the same as push at the bottom, so it's 1 over 3 to the positive 2 power, which is 1/9. So that goes right here as 1/9. Okay? Then I got 3 to the negative 1 power, which again is the same thing as putting on top, so 1 over 3 to the positive 1 power, which means it's 1 over 3. This is 1/3. Okay, so 3 to the 0 power, same thing as 1, so this becomes 1. 3 to the first power is just 3. And 3 to the second power is 9. So it just becomes 9 right there. Okay? So now we got our table filled out. Okay, and these points go on to the graph. Alright, so our first point over on the graph here, we'll slide this over. And we've got a negative 2 over and 1/9 up. It's very kind of above the line right there, so the graph's right there. And then we got negative 1 and 1/3 up, so 1/3 of the way up is right there. And these should be really close. That's what kind of happens. And then the 0 and 1 goes right here. This is what kind of makes the curve. And then 1 and 3, so 1 over and 3 up goes right there. And the last one is 2 over and 9 up, so it goes clear up here. This is what a curve, exponential graph should look like. Should run along the line here like this, not crossing that line. We'll talk about it in just a second. And turn a hit and go those lines and curve and go up and go like this. And that's what an exponential graph should look like. Okay? Now, this line right here that this does not cross, these lines, these points will never go to 0. So this is kind of trick. If I have negative 3, this becomes 1 over 27. And negative 4 power becomes 1 over 81. These numbers keep getting smaller and smaller and smaller, but they never go to 0. So that means that there's a line right here. Okay? And that line we like to call it, an asymptote. Okay? So an asymptote is a line that cannot be crossed. So this line right here, this graph will never cross this line right here. Okay? That's its asymptote. Its asymptote is the line that this graph will not cross. And it's just because these numbers get smaller and smaller and smaller, they'll keep getting closer and closer and closer to the 0 line here, but they'll never cross that 0 line. Okay? All right, now for the next fun part, we're going to do this in a different way. We're going to do this one, same idea. We're going to go down here and solve this same way. We're going to get a table of values going here. I think I'll do it over here. That's it right here. Okay, we'll do this table of values right here. This is x, and this is f of x. Same thing as y, remember? Same thing. And we do negative 2, negative 1, 0, 1, and 2. Except this time we're going to do them with our calculator. Okay? So, I'm going to put these on my calculator, I'm going to get these numbers there. So if I get the glare off this, okay? We'll get the glare off this calculator, I'm going to do these things. So here we go. First one, we're going to turn this on, clear this, do a second, plus 712 to clear this. Okay, so we got this cleared. Now to take our power here, we're going to go 1/2, so 1/2, put it in fraction mode, times parentheses 4, close parentheses, we're going to put a power here. We're going to put our negative 2 power right there. Now it's going to give us a decimal point. We need that in fractions, so we're going to hit the math key and hit enter twice to get the fraction of that. So this is 1 over 32. So this one's right here is 1 over 32. So 1 over 32 right there. Okay. Then we got to do that negative 1. Now to do this, I don't retype it again. I just go slide up here, arrow up with my thing, highlight that, hit enter, go backwards arrow, get that to on the 1, change it to a 1, hit enter, and again it's decimal, so I got to change it into fraction. So a math key, enter twice. This is 1/8. I'll put this over here so I can use this better. So this is 1/8. Okay. Then we do the same fraction with the 0 power. We're going to go up here, arrow up to the equation, hit enter. We're going to change this to 0 now, so the -1 there. Hit my delete key, delete that off, change that to 0, hit enter. This is 1/2, so I'll put this right here. And then go up here, do it again. We're going to do first power now. And 0 back, we'll change that to 1. This becomes +2. And if you think about it, what happens is 4 to the first power is 4, then 1/2 of 4 is 2, so that works. Now we do our second one. We're going to put our second power up there. So we're going to scroll up, highlight that, and change that to second power. Again, but if we do this, we can do this in our head. 4 to the second power is 16, and 1/2 of 16 is 8, so this answer should be 8 when I do this one. Okay? Alright, so there's my numbers on my calculator. We'll come back to that in a minute. So now I've got them on my chart filled out, and I always fill these charts out as I go. Okay, so I'm going to graph this now, over on this graph. Okay, so my first one is -2 and 1/32. So look how small that's got to be, really close to the line, so we can just kind of barely guess where it goes right there. And I've got -1 and 1/8, so again that's just barely above the line here too. And I've got 0 and 1/2, so halves will be right there. And I got 1 over and 2 up goes right there. And 2 over and 8 up, so 2 left, 2 right, and 8 up goes right to there. And so my line comes across here like this and goes up some like this. There's my graph. Okay? Not bad. And again, it does have an asymptote that's going to go right across the bottom here. It will not cross this line. And asymptote will change depending on what happens to the equation, but these simple basic ones like this will usually have an asymptote of 0. Okay? Alright, the last one here then, we're going to do this one, we're going to graph this in the same way, we're going to get our table of values going here. This is number 4. Okay? And we're going to do this a little bit different on the calculator. So this is x, this is h of x this time. Okay, we're going to put -2, -1, 0, 1, and 2 here. And then back to our calculator again, so we're going to put the calculator up here and get these numbers in here. Okay, so get me some room here, give me some numbers in here. Oh, I got to see my function. Okay, give me my function. Okay, so my function is going to be right here. So we're going to put that in, but we're going to do this. I'll do it like this, and I'll put the calculator up. You can see what I'm doing. So let me get back my calculator on. Clear this, and now to do this, you just try to do this really quick. So what we're going to do is we're going to use these buttons right across here on the top of the calculator. So I'm going to go to y equals first, okay, and then I'm going to put this in my calculator. So I'm going to put parentheses, 3, make it fraction, 5, slide over, put my parentheses in. Now here's the tricky part. Okay, when I go to my power, I need a variable there. I don't want a number there. So the variable key is this key right here. On the calculator is this key right here, right next to the green key. That's my variable key. It has x, t, theta, n on it. So I put my variable key there. You'll see that on my variable key, it puts a variable in there. And that's what I want. I want that x to be like that in the variable. So what I do then is I make my calculator graph the function. So I tell it to hit enter. And I hit my graph function, and it graphs the function for me, so my graph should look like this when I get done. Okay, and that's not the important part. The important part is what comes out that. I want to look at the table. So my table matches this table right here. This is my t table here. So right here on my calculator, right above the graph key, it says table. So I'm going to hit my second key, and my graph key is going to show me the table. And this is where I'm going to get my numbers from. So I want to look at -2, so scroll up to -2. This number is 25/9. So this becomes 25/9 right here. At -1, I get 5/3. Okay. At 0, I get 1. At 1, I get 3/5. And at 2, I get 9/25. So I get all the numbers by using that graph function. And again, I can see what my graph should look like when I get done. So I go over to graph my function. I can kind of mirror this. I'm going to put these on this graph over here. Okay, so I can put those in. So I got -2 and 25/9. That should be up here. It's almost 3. So I'm going to put up here almost 3. 25/9 is right there. Okay, then I got -1 and 5/3. So -1 and 5/3 is 1 and 2/3. So I'll be right there. 0 and 1 is right there. And 1 and -1 and 3/5 is right here. And 2 and 9/25 is down here close. Again, this line's going to curve like this, going to come across here and go up here like this and go up. Okay, and it should match my graph that I have in things, so it should be pretty close to my graph there. And again, this is my asymptote line across here. Okay, but it won't go to 0. All right. Okay, the last part of Unit 5 is to move this. Now this is weird. I'm going to move this graph. So this is my normal function, my first graph. That's what the line drawn over here is, that first function. And when they do this, they change the exponent to them with an x minus 3, and then they put a +2 on. That affects where this graph sits in the graph. It moves it around the graph. But this moves it counterintuitive. Well, this is x minus. We're used to minus being going to the left, but with the x minus 3, this is moves it. Okay, it moves it left and right. Power moves it left and right. Okay, but it's counterintuitive. Means, yeah. Means that it moves it. We don't think so. Minus, we used to go like left, but in this case, it moves it right 3. So I'm going to move the graph right 3 instead of left 3. Okay, so it's always backwards. Now this one moves the graph up and down. Okay, and it's the same normal mode. So if it says positive, we go up. If it's negative, we go down. Okay, so it moves it normally. Okay, so this graph is going to go right 3 steps and up 2. So we take this graph, take this point right here, the intercept, and we move it right 3. So we're going to go 1, 2, 3 to the right and up 2. There's my new intercept right there. So my graph then should come down like this, intercept right there, and go across right like that. So there's my intercept graph. Okay? And that's how we do number 1, 6.1.